Fair Venus shines even in the eve of day, with sweetest beam, propitious shines and shakes a trembling flood of softened radiance from her dewy locks.
Den interplanetære podcasten. Utforskning av rom til fordel for hele menneskeheten. Dine verter i England og Norge, Matthew Russell og Chris Carney.
Oh yeah, baby. Babble.
Anna Babbo, I think it's pronounced.
Anna Letitia babbled. Babble?
Babbo.
Babbo.
I think she probably had a kind of, it was at that time where the English and the French were almost indistinguishable.
Yes, yeah.
Somehow,
were,
that sort of, they're sort of upper classes.
Yeah.
Intermingling.
In the 18th century, everyone loved each other and got on, and there was no wars, there was no...
18th century was, no wars apparently in the whole thing.
No.
Particularly in Europe.
It's a good time for everyone.
I thought we'd start with something beautiful about Venus, because Venus deserves to be treated with utter reverence, doesn't it?
Absolutely.
As a planet, don't you think?
I think so. It's stunningly beautiful, even though it's hellish.
Hell on earth. Before we start talking about Venus, I want to shout out to 4 patrons.
Mm-hmm.
The greatest of the patrons. That's the 2 Justins, as always. Justin
squared.
Young and Justin Roberts. And Drew Wright and Sigmund Sio Eid.
Thank you very much, patrons.
Well, it is hard to put a price on that, because they keep this going, particularly during lockdown. These guys have kept the whole thing on an even keel and wiped its nose and kept it going. So I cannot thank you enough. And actually, all listeners should thank these guys, because they're the best. Thank you so much.
Thank you so much.
Thank you all. And that's quite an international crew there as well. I'm also going to thank Tupper Hyde, who's another patron who hooked me up with the interview this week.
Nice.
And it's a really timely interview as well. It's a guy called Mike Sekerak. I believe that's how you pronounce his name. It's quite difficult.
Seems close enough.
He's the Deputy Project Systems Engineer of Lucy, but he's also the lead engineer of this latest mission to Venus, Davinci Plus, or Davinci Plus.
Davinci? Davinci, you say?
Davinci.
Don't touch
Davinci
Davinci.
Plus. Talking of Davinci, Venus rhymes with, and despite that, it's we often associate it with the feminine, don't we?
Yes,
Venus.
we do.
It's even named after the Roman goddess
of beauty. I always thought it was goddess of love, but the goddess of beauty is more
beauty.
apt.
Beauty. Yeah, goddess of beauty. Oh, Venus. And it's often referred to as the Russian planet, particularly by the Russians, who I think, and I can understand why, because what I'm gonna do before we get to the interview, Chris, is have a little rundown of all the time that we've been to Venus.
Yeah. Okay. That sounds good to me.
The significant times we've been to Venus, because there's quite a lot of flybys and gravity assists.
Yeah.
Because even Bepi Colombo had a little swing by quite recently.
Oh, Bepi.
But did a little bit of measurements of the atmosphere and things, just so we learn a little bit more.
Yeah.
And obviously Venus has been in the news because of phosphine and stuff like that. But it's actually really interesting, the missions that have gone. So get this, in the 1960s, there were 18 missions to Venus. Like you'll actually see how Venus changes in priority.
Yeah.
Because there was 18 in the 60s, there was 11 in the 70s, 8 in the 80s, 1 in the 90s, and that was just a flyby by Cassini.
Yeah.
There was 2 in the 2000s, 5 in the 2010s, but that's because it was a bit of a bump, but that's mainly Japanese entering into the Venus market, as it were. And there's only been 1 or 2, actually, if we include the Bepi Colombo, flybys in the 2020s so far.
Well,
so far.
It's kind of early.
But you can see there's a bit of a sort of downward trend.
Yes, definitely.
Of visits to Venus, particularly landing on the surface or going through the atmosphere. I mean, it's pretty bonkers.
I guess everyone's facing the other way.
Everyone is facing the other way. It's like Mars has drawn our attention. But why is that?
I don't know. It's just better.
Mars is better than Venus.
No, I think it's obviously the distinct possibility of habitability, but it's not like Mars is a very friendly place to live. But
no,
it's obviously, you've got the chance more to try and colonize, more to try and build bases. Whereas if you tried to build a base on Venus, it'd probably melt.
Yeah, more than probably. But we've had this before, where you could potentially build cities floating in the sky, because 30 miles up, it is similar pressure and temperature to Earth, and similar gravity, of course. So that would be all right. And of course, life may have retreated there, because what's amazing is only 715 million years ago, there may have been oceans on Venus.
Wow.
And that's only 715 million years ago.
So yeah, that is amazing. I didn't actually know.
There may have been plenty of time for life to have started on Venus, in which case, like, life being in the atmosphere might be a distinct possibility if life was abundant at one point, and you know how life likes to cling on. Not Klingon as in Star Trek.
Not the
aliens,
Klingons.
But not the Klingons, but you know how life likes to cling on. Mariner 2 is the first real successful mission to Venus. And that's the Americans, 14th of December, 1962. The Russians and the Americans had tried lots of times, but they'd all sort of blown up on the launch pad, it seems, or just lost in space.
Yeah.
But Mariner 2 is the first probe that had a planetary encounter. So it's the first, space probe that's gone into space and been by a planet. So it's a flyby, but still pretty impressive.
Yeah.
But it's at this point the Russians just totally start kicking ass. So Venera. So guess what Venera means in Russian?
Oh, I don't know. It sounds a bit too close to venereal, but
well, maybe venereal actually has the same root, actually.
Oh, because of Venus.
Venera obviously means Venus.
Yeah.
Venus.
Yeah, I get it.
Yeah.
Cool.
So Venus 4, the Russian Venera 4, actually returned atmospheric data 18th of October 1967, right? And it was the first spacecraft to sort of float down through the atmosphere.
Yeah.
As we'll hear in the interview, it's not like something falling through Earth's atmosphere, this big heavy ball falling through Earth's atmosphere. It's more like throwing a pebble into the sea and the way that a stone might move through water, because the atmosphere is so thick.
Yeah.
Which is interesting, isn't it? So it takes almost an hour to get to the surface if you're falling through.
Because it's more like sinking through an ocean. That's amazing.
And the same with Venera 5 and 6. They drop down into the atmosphere. So there's these like kind of probes that sort of fall down into the atmosphere. There was a few before, obviously, Venera 4, and they all blew up on the launch pad. But that's the kind of, hard end of this. We're still in the 60s here.
Yeah.
So this is while the space race is going on. Russia are definitely winning the space race.
Yeah.
When it comes to how good they are at going to Venus. That they are the best, right? So Venera 7, it had this it's got this actually amazing parachute design.
Yeah.
Where the parachute opens up a bit, and then there's this reefing line that keeps the parachute not fully open, and that slowly melts. And as it melts, it allows the parachute to open more and more as it drifts down to the surface. Which is a pretty cool mechanism.
The fact that they knew that it could do that in 1970 is just astonishing.
Yeah. That is absolutely amazing, isn't it? It landed a bit hard because that parachute actually failed eventually. So it hit the surface at 37 miles an hour. Now, obviously, it'd be going a lot faster on Earth because it wouldn't be slowed down by this thick atmosphere. So that goes to show, just how thick the atmosphere is, that like a giant metal ball is still only going 37 miles an hour when it hits the surface.
Yeah.
From that rapid halt in its trajectory, they were able to get the data back from that and conclude that there's a very hard surface, that Venus wasn't dusty. It was just like it had been paved or something like that, right? So it's like, oh my God. So like Venus is a very, very hard, totally dustless surface. And they may have, I suppose, lucked out a little bit there. But it also found things like the surface was about 475 degrees centigrade.
That's a little bit hot.
Which is like twice as hot as my oven goes to.
Yeah. And you don't want to go in your oven. So
I definitely don't want to go in my oven because that like cooks pizzas in 10 minutes, doesn't it?
But you get a pizza done like that on Venus, pizza's ready quick. You know what I mean?
Oh yeah. In fact, Venus is probably ace for cooking pizza because of that hard surface as well.
Yeah, completely. Yeah,
you don't get a soggy bottom.
You won't get soggy bottoms, and that's nobody wants that.
No. But it also found that it was 1,300 psi down on the surface as well, which is about the same pressure that you get half a mile deep in the ocean.
Wow!
So that's a very crushing atmospheric pressure as well.
I put about 110 in my bike tires.
I don't go up to 110. You're a crazy man. I'm
a lunatic, aren't I? Just what am I doing to myself? Saddle sore. That's what I'm doing to myself.
Yeah, that is saddle sore time. But yeah, because it hit so hard, it rolled over, and the medium gain antenna wasn't quite pointing at Earth properly. And they actually thought they didn't get any information at all. But someone actually, this bloke Oleg Riziga, double-checked the data and found that the tapes weren't completely empty. The tape recordings of the signal actually had this tiny signal, and they were able to get all this information from it. So Venera 7, even though it was a slight failure because of this parachute issue, really is the first soft landing on another planet. And Venera 8 in 1972 pretty much repeated the trick, worked for 50 minutes on its descent.
Yeah.
And showed that the clouds, like the thick clouds, ended quite high up. And after that, it was relatively clear, just like it is on Earth. They were able to tell loads of things about the actual rock as well from Venera 8. Venera 9, so the Russians are killing it with their Veneras. First image from the surface of any planet.
I'll have to have a little look at that.
Oh, it's quite good because it does look like it's landed in a car park. It really does. It looks like a car park that they're just pneumatic drilling to get up. So like it's like all broken up.
Yeah,
it looks like a broken up car park basically.
It does, yeah, brilliant.
Which I guess for a planetary surface is still quite smooth. It's not like trying to land on the moon or Mars where it's quite rubbly.
Yeah,
and it's got a similar. They're able to tell that it's sort of similar lux, 14,000 lux that the Earth gets in daylight if it's not direct sunshine. But it's really cool how it protects itself as it falls through, because it's using its shape almost to slow itself down. And so you don't need the parachutes all the way down. And then when it hits the ground, you had this like disc that crushed itself as it hit the ground and act like a sort of donut shaped cushion.
Yeah.
And sort of crush down when it hit the ground. So you could hit it quite hard. But that you don't get a 360 panorama with it because one of the lens caps failed to come off, which exactly 3 days later, Venera 10 did exactly the same thing. Pretty much identical mission, but 3 days later. And the lens cap again didn't come off. So they've got two 180 panoramas that look very similar.
You'd think like maybe the other lens cap wouldn't come off, so they'd have a full panorama.
It's pretty annoying. So the Americans now are catching up. So in early December 1978, so Russians at this point in the 60s and early 70s, they've absolutely killed it with Venus
completely.
But so there's these pioneer missions called Pioneer Venus 1 and Pioneer Venus 2. Venus 1 is an orbiter, and Venus 2 is an atmospheric craft, and they both arrive early December 1978. And Pioneer Venus 2 is 4 probes, 1 big one and 3 small ones, and they all went into the atmosphere. There's no cameras, and they weren't designed to survive landing. But they showed the similar sort of data to the Russian stuff, that the temperatures were between 448 degrees centigrade and 459 centigrade, that the ground pressure was between 86 and 94 bar. So like ridiculous, but it also showed that there was this weird argon isotope ratio, which is completely different to Earth. So they think that the way that the Venusian atmosphere was made was completely different to how Earth's atmosphere is made.
Right.
So it's like that is a pretty major scientific discovery, and the orbiter stayed right up until the early 90s. It was still in operation. And a few days later, Venera 11 and 12, at Christmas time, 1978, weren't quite as successful as the previous ones, and they failed to get any pictures back. So the cameras failed, but they did also report this argon ratio and discovered carbon monoxide at low altitudes.
Right. Not a friendly place to be, as we've covered.
No. So it's like being boiling hot, crushing, and like putting your mouth over the exhaust pipe of your car. It's all right, isn't it? Let's go on holiday. So maybe I can see why people prefer Mars. Venera 13, first recording of sound from another planet, 1982.
Fantastic. Amazing.
Also managed a colour panorama. But my favourite little anecdote of this is there's a guy called Leonid Kasanfomalati or Kasanfomalati. Kasanfomalati. Doesn't sound Russian, does it?
No, he sounds more like Italian.
Yeah, it does sound Italian, doesn't it? But he was part of the Venera team. But he wrote a paper about how the picture shows this object that moves. It's like, see this object moving? It's like a scorpion.
Yeah.
And he was convinced that the photos showed that there was life on the surface of Venus. These scorpions on the surface of Venus. But it turns out it's back to those lens caps again. It was the two lens caps that were on the floor that he thought was the same lens cap, but they're actually two different objects. So it wasn't something moving. It was just the two lens caps.
They look exactly the same. They're in a different place. I could see how he would think that. And lens caps do look a lot like scorpions.
Venera 14 again was one of these. I know it's ridiculous. Venera 14 was one of those things that was one of the probes that landed a few days later, so a little bit after Christmas, and also did exactly the same thing. Took a color panorama, this time 360, just like Venera 13. And if you go into Don P. Mitchell's website, he's got reprocessed color images of those pictures that they take.
Cool.
He's managed to find a way of actually getting more detail out of them. So, those still remain the greatest pictures of the surface of Venus that you can get, the Venera 13, Venera 14. Venera 15 and 16 were just orbiters, right. Although Venera, I believe 15 was the first high-resolution radar mapping of Venus. So Venera basically kicked ass, didn't it?
Completely. Yeah, absolutely nailed it.
And it's not over there. It's not even over there. So the Russians then set up this thing called Vega. Now, I thought Vega would have just been named after the star, but it turns out that it's one of those things where what do you call it when you push two words together?
You could call it a compound or a portmanteau.
Yeah, like when you chillax.
I hate chillax.
Why don't you just chillax about it, though?
Oh, God. Don't do it to me. Don't start saying game changer as well. Game changers is my head in.
Well, this was a game changer. So Vega is actually, is Venus and Halley's Comet combined. So I think Halley's Comet in Russian is Galeya. And if you combine Venus and Galeya, Vega, it's Vega. So Vega, that's what it's named after. And I never knew that. So the mothership that was taking these two Venus probes then used a gravity assist of Venus to intercept Halley's Comet.
Nice.
So it's like a double mission, Venus and Halley's Comet for the price of one.
Fantastic.
The probes themselves didn't take images because they landed on the night side of Venus, so there's obviously no light. But the cool thing here is that they had a balloon on board.
A balloon?
In both Vega 1 and Vega 2, because again, the Russians seem to like sending these things in pairs, one arriving 3 days after the other. In both, balloon is sort of pulled out by a parachute at about 61 kilometers altitude. Then another parachute then pulls this filled balloon out. Then the balloon inflates Then the parachute and the inflation system are jettisoned off. And then this ballast is also jettisoned off at roughly 50 kilometers. And then the balloon floats back up to a stable height of about 53 or 54 kilometers.
Fantastic.
And then just starts making its way around the entire planet at this stable height.
Huh.
So at that point, it's only 535 millibars of pressure. Temperature's about 300 Kelvin. And so these balloons were allowed to just sort of drift around the planet and sort of manage about 30% of the circumference of the planet, taking measurements.
Whew.
1985 era is the last time that we really sent anything into the atmosphere of Venus.
Know everything, don't we now? Just know not more to learn.
We definitely don't know everything, as we'll get to the interview, which is really exciting because Davinci Plus is another one of these probes that sort of drifts through the atmosphere like a pebble in the sea. But I won't want to spoil it to you. I'll get the lead engineer to kind of explain that one. But
sure.
Magellan is obviously a big American one at this point. So 1989, Magellan, they launched that from Atlantis. So it's the first interplanetary probe to be launched from the space shuttle.
Incredible.
Actually, flung it out the cargo bay of the space shuttle, makes its way to Venus for 10th of October 1990, and then it mapped the surface and gravitational field for about 4 years while it was in orbit there. So incredibly important. And then it was programmed to burn up in the Venusian atmosphere. Then 2006 is Venus Express. So it's only like 2006 that the European Space Agency send a probe to Venus. Isn't that surprising?
Behind there, guys. A little bit behind, but
Yeah. And it's even launched on a Soyuz, so it's a bit of a kind of with Russian help.
Well, it's going to the Russian planet, so
well, exactly, yeah. So they know how. I suppose they know how to launch to Venus by now.
Yeah,
yeah. But Venus Express has been incredibly scientifically important. Confirmed things like the presence of lightning, and that lightning's actually more common on Venus than it is on Earth. And I always find that fact about Earth's being struck by lightning 6 times a second, or something even more ridiculous than that, isn't it?
Yeah, it's incredible.
So it is ridiculous. And it also reported these huge atmospheric vortexes at the South Pole as well of Venus. So, and this evidence for the past oceans, I think, comes from Venus Express.
Sure. So because of how different the makeup is of the atmosphere and things like that, if there was a potential life story from 1 billion or so years ago, what life are we talking about in that kind of, I don't know, in that kind of makeup, that kind of planetary makeup? Was it ever similar to Earth, or are we talking about literally different elements making up its...
Well, it's weird because for a lot of Venus's time, maybe for billions of years, it was an utter sister planet to Earth. And I think this is the mystery. It's like you've got these two planets that are almost identical, like identical in size. They've got a similar core.
Yeah.
There's not really much of a difference. With similar distances from the sun.
Yeah.
Yet our trajectories have obviously taken insanely different routes.
Yeah.
And I guess that is the core of the mystery, is what happened to Venus or what happened to the Earth that allowed, we might be talking, like we were talking earlier before we came on air, about like the Fermi paradox. Well, if you're talking about great filters, maybe Earth avoided a great filter when it comes to the type of atmosphere that we have.
Yeah.
Because it's quite improbable that you can release lots of oxygen into the atmosphere without there having to be some form of life there to do it.
Sure. Yeah. I mean, it's like, we're looking at what could have been about 4 billion years or so on Mars, where there's a chance that there could have been an Earth-like sort of atmosphere there, which then something happened, something's changed that, and I mean, because Venus has got the type of atmosphere clearly that lets all the radiation in and then doesn't let go of it, and that's
No.
basically.
Yeah, but that's because I mean, but if carbon dioxide builds up in the atmosphere, like it would do if you just have mitochondrial life, animals, breathing out carbon dioxide, and eventually you just get a runaway greenhouse effect.
Yeah.
Or if you just had plant life breathing out oxygen, then you get a snowball of Earth. But if you have both forms of life starting roughly at the same time, then you get this balancing effect. It's insane. It seems very unlikely. I mean, life seems unlikely as it is, but it's almost like you have to have two unlikely events happening at the same time.
I think it was God.
Maybe that's one of the great filters. But of course, that's why Venus is really, really, really important to understand what on earth's going on, which makes it the more confusing that the only operational probe out there at the moment is the Akatsuki Dawn probe. Akatsuki. Japanese.
Yeah,
Japanese.
so.
Of course it is, because it's got a nice name.
Yeah.
Although they tend to repeat their names, which is pretty annoying of the Japanese. But Akatsuki, that's the only one out there, and that's one of my favourite spacecraft because it actually missed getting into orbit. It was supposed to get into orbit around Venus in 2010, and it failed to do a burn, so just went flying past.
Yeah.
And so the guys had to work out how to get it into a different orbit. And it took another 5 years to get it back to Venus, to get it in orbit. And you think, God, which obviously must massively reduce its lifetime in orbit, because obviously they must have had to have burnt up a load of fuel to do it.
Yeah.
Fair play, the fact that they managed to do it. It's like you've gone past, and it's like, oh no, well, we're going to spend 5 years getting back. It is just like being on the M25 when you miss your junction.
Yeah.
And then you look on the other carriageway and there's a massive traffic jam.
Yeah.
And you go, no!
Yeah. I can just imagine one of the engineers sort of going, right, that's me, I'm going home. The dinner's on, you know what I mean? Hang on a minute, John. Just hang on a minute. Yeah, you're going to be here for another 5 years.
At least we've got to work this thing out. Yeah, so but that's the only one out there at the moment. It's the only one out there, and there's the odd thing doing the odd flyby, like I said, Bepi Colombo and things like that. But that's the only thing that's out there orbiting. So the announcement the other week that NASA was sending 2 new missions, and discovery programs are big. These are big missions, and both of these missions actually didn't get selected the last time because of Lucy and Psyche, which are 2 of my favourite missions. Obviously, Venus is sort of edging its way back up the agenda a little bit. I mean, there's loads to talk about, isn't there, with Venus? You've got its similarity to Earth and why all that happened. But just the fact that there is this global warming element to it, isn't there? Of saying, if you can understand the processes of how you get a runaway greenhouse effect, that seems to me like it could be a useful and a critical thing to understand, right?
Completely. Yeah, without a doubt. I mean, it is literally, we've got a model for what can go wrong, basically.
I was really lucky enough to talk to Davinci Plus's lead engineer, and so do you want to hear the interview?
I would absolutely love to.
Here it is then, Chris. A Kotai.
The Interplanetary Podcast, putting the ace back into space.
So I'm joined on the podcast, very excitingly, by Mike Sekerak from NASA. Welcome to the podcast, Mike.
Oh, thank you. Happy to be here.
Mike, you're involved with perhaps one of the most exciting announcements for a long time, and that's the Davinci Plus mission that's just been chosen as a Discovery class mission. First of all, tell us what your involvement is before we go on to the actual mission itself.
So I'll be the project system engineer for the mission. As a project system engineer, I'm essentially the lead engineer overseeing all technical aspects of the mission. So I'll oversee the spacecraft development, the probe system development, the flight dynamics, the ground communications, interfacing with the launch vehicle, all the different technical elements for the mission. I'll be the engineering technical authority overseeing our successful reentry into the Venus atmosphere.
That is a very responsible job. We'll get on to how you got there. Have you been involved with the Davinci Plus since it became Davinci Plus after it, when it was Davinci, it lost out, didn't it? Davinci lost out to Lucy and Psyche in the last round of Discovery.
It did, in fact. So there's actually quite a bit of history of Venus probe development at NASA Goddard. For well over 10 years, various different engineers and scientists have been working to try to get another probe mission to Venus, led from Goddard Space Flight Center. The last actual probe mission from the U.S. was the Pioneer Venus Large Probe, and that was at the late 70s. And there's been a huge amount of advancements in scientific understanding and instruments and technology since then. And so we've been doing a lot of development again over the past decade. And yes, back in the 2016 Discovery round, there was also 4 finalists, and unfortunately, both Veritas and Davinci lost in that round to Lucy and Psyche. I did end up joining the Lucy mission after that selection, so I've had the privilege of being on that mission basically since selection. But this time around, in the 2019 Discovery selection, which was announced last week, it's Venus's time for both Veritas and Davinci Plus.
I remember covering the story of Lucy and Psyche, and I must admit, I absolutely love those missions. I can't wait for both of them because they're extraordinary. But I am also a massive Venus fan, and the fact that we haven't been there for so long.
There were some late 80s Venera missions, which were the Soviet missions that went down there in the early 80s. But it's really been well over 30 years since anyone's really gone below the clouds of Venus, and there's just so much to learn. I mean, there has been other missions on the interim with Jackson and ESA, but there is so much that we can understand by going down to the surface. Those clouds are so thick and so hard to penetrate that you really need to go down and take samples of the atmosphere to understand what's going on underneath, to correlate with some of those orbital measurements.
Now, there's a little bit of me as when this announcement was made that it was relating to the phosphine announcement. What is there some truth to that? Is the phosphine announcement, did it make, even though it's sort of turned out to be a little bit dubious, did it make going to Venus much more of a priority? Did it kind of go, yeah, we should really check out Venus a little bit more, or has it been a much sort of longer story than that?
I'd say it's a much longer story than that. Exactly how headquarters weighed that in the decision. I wasn't part of those discussions. But certainly Venus has gotten a lot of attention recently. The phosphine in the news last year, and again, there's a lot of scientific debate about that. Most certainly helped. I mean, the Venus community has definitely felt a bit neglected with the last New Frontiers round, where Dragonfly was selected, as well as the last Discovery round, as you alluded to. So there's been a lot of outstanding questions that the Venus community has wanted answered, and the phosphine really definitely kind of helped amp that up, if you will, to really put it kind of in the broader public space. If there's a question of a possible biological signature, and really the only way we can do that is to go there and take measurements. And fortunately, Davinci is the perfect spacecraft to be able to do that with the instruments that we have, particularly our Venus tunable laser spectrometer. We'll be able to help provide some of those measurements that have only been done remotely, and hopefully help settle the debate in terms of the scientific importance of that. That will be debated for a long time, but to get those definitive measurements that help inform that debate, we'll be able to do that.
Yeah, so tell us a little bit about the overall mission architecture. When does it launch? How does the spacecraft operate? What's the whole thing? What's the whole deal?
Yeah, absolutely. So right now we are still negotiating with headquarters on exactly when our launch date is going to be. Right now we're targeting somewhere in the late summer to early fall of 2029. And what's really exciting is, so we have a spacecraft, and we also have the actual probe flight system. So the spacecraft acts as a relay, as well as has some instrumentation on board. Then we have what's called a probe flight system, and it basically looks like a big cone, and that is the structure that actually enters the Venusian atmosphere. And inside of that is approximately 1 meter diameter titanium descent sphere, or that's the actual probe itself that goes down. It'll go all the way down to the surface, although we are not required to land, which is an important distinction. That'll take measurements all the way down, going down to the surface. So again, we launch in mid to late 2029, and we do our first flyby of Venus in the February to March of 2030 timeframe. And during those flybys, we're not just doing gravity assists there. we are doing gravity assist, but we are also taking level 1 science while we're there with our both visor and Cubis instruments. We'll be taking science measurements during flyby 1 and November of 2030 and flyby 2. We taken measurements as well. So only half a year or so after launch, we'll be getting some important science measurements. A lot of interplanetary missions take much longer. For example, the Lucy mission that I'm on, we launch here this fall in October of 2021, and we don't start getting our actual first main science measurements until 2027. So we start getting science right off the bat. But the real big show is going to be in June of 2031. And that's when the spacecraft spins up. It releases that probe flight system. The spacecraft continues on flying past Venus, and it points its big 2-meter diameter high gain antenna down towards the probe as it's entering. And then the probe then enters down through the atmosphere and then starts taking data from about 6 to 7 kilometers up all the way down until the surface, constantly beaming it back on an S-band frequency back to the spacecraft. I'm taking measurements with our Venus mass spectrometer, which is a quadrupole mass spectrometer, our VTLS instruments, which is the Venus Tunable Laser Spectrometer. We have our VENDI, the Venus Descent Imager, which will be taking pictures from about 40-ish or so kilometers down below the cloud deck all the way down to the surface. And then we also have VASI, which is the Venus Atmospheric Structure Investigation. And it's a suite of sensors that will be taking temperature, pressure, and accelerations to make sure we understand the makeup of the Venus atmosphere during the entire descent. And we also have VFOX, the Venus Oxygen Fugacity Sensor, which is a student collaboration that'll be mounted to the outside of our dispense sphere to measure oxygen. So we'll be taking actual samples, we'll actually be tasting the atmosphere and taking basically a chemistry lab that's flying all the way down through the atmosphere, and then taking pictures, especially as we get down closer. We'll get around meter resolution as we get towards the end of our descent.
Quite a suite of instrumentation. Do the instruments on this type of probe, have they been already tested on other spacecraft and robots before out in space, or do you have to start from scratch with a lot of this stuff?
No, actually, they have been, a lot of them have been tested before. So our 2 mass spectrometers, VMS and VTLS, actually flew, very similar versions of them flew on the Curiosity rover. So they're part of the SAM instrument that is taking very similar measurements on Mars. So we've already proven out that those instruments will work in a space environment. So there's no new technology there. Now, of course, packaging them into the descent sphere and making sure they can work in the one time that we have to make them work versus the descent sphere is going to take extra testing and take a little bit of engineering work, but it's not new technology development. The camera, the Venus Descent Imager, made by Malin Space Science System. They've made a lot of cameras before. A lot of the missions that you talk about on the podcast is taken. Malin cameras have gone there, and in fact, Mike Revine from Malin said this Venus is the last one he hasn't imaged yet, so he's excited to send a camera there. And then the VASI instrument it's a suite of sensors that have already been proven, and really the temperature and pressure measurements aren't that new, but how we build that up into an atmospheric profile will be what gives us the new information.
It's 2021 and you don't launch till 2029. How much does a spacecraft like this actually change in design, or is that it? You've got pretty much got the design. You've just got to make that as robust as possible.
Yeah, we pretty much have the design. We're just going to make it robust as possible. With these discovery missions, they're cost cap missions, so we need to be very mindful of scope creep. I mean, would we love to pack even more sensors on there? Of course, any science team would. But to make sure that we don't have scope creep, make sure we can keep within these cost cap missions, we do need to be very mindful of trying to infuse a whole bunch of new things at the last minute, because while they may be great, that could cause for mass and cost growth and schedule issues. So the instrument design that we have right now is going to be what we fly. Of course, there's some engineering maturation that, of course, will happen between now and 2029. There's some technical questions, of course, that we need to address as we refine the designs through our preliminary design review process, our critical design review process, and of course, fabrication and testing. But what we have right now is what we anticipate flying.
Have you ever been in a situation where there's been a breakthrough in say instrumentation engine, and like an engineering or scientific breakthrough that has radically changed a spacecraft design in these sort of long build periods? Or does that just never happen?
Well, I'm sure there's definitely some examples that have happened. but unfortunately, within the aerospace world, things do move. They move pretty darn slowly. I mean, the processing power you have in your cell phone compared to the processing power of our spacecraft, there's an inherent lag there. We can't turn things around quite as quickly because the environment is harsh with the thermal extremes, the radiation. So there's a lot more testing that needs to be done for any spaceflight hardware than versus what you used to come out, kind of commercial consumer hardware. But a lot of these developments do take time. It's unusual for development to have a radical breakthrough that is immediately ready for flight implementation. So my doctoral work was in advanced spacecraft propulsion. I did plasma physics for Hall effect thrusters, and they've been in development for quite a while. And new advancements, while we have made some new advancements in that technology, for them to go from a new idea in the lab or proof of concept until something's ready for flight, is usually a decade-long process. So a new radical idea being implemented for flight takes too long to implement in this type of cost-constrained, fairly rapid turnaround mission.
And I'm assuming, I don't know why, but I'm assuming that this you've just brought up ion thrusters. I'm assuming that this spacecraft is a chemical. An all-chemical affair, right?
yeah. This one is an all-chemical propulsion system. No ion thrusters here.
How long is this descent stage?
It'll take about an hour to descend through the atmosphere. So our nominal mission is right around 60 minutes, plus or minus a few minutes or so. And we have to do some very careful modeling. It's a big Monte Carlo analysis because, of course, the atmosphere changes. There's high winds. I mean, the Venus atmosphere is a pretty nasty place. Even though it is our sister planet, it's close to us in mass, and distance from the sun. It's not that far off. But obviously, the conditions at the surface, where it's about 900 degrees Fahrenheit, about 480 degrees Celsius, about 95 atmospheres, sulfuric acid droplets in the atmosphere. I mean, it's not a pleasant place to be. So you have to design something that is able to survive in that environment for the period of time that you need to be able to get the science measurements back. And so from when we start taking our science measurements all the way through down to the end, which again will be transmitting all the way down to the touchdown, then we will. It's about an hour for that total descent. And it's a carefully choreographed, as you can imagine, very carefully choreographed hour of measurements.
So presumably there's different suites of instrumentation coming on and off as you go through the different layers of the atmosphere.
Yeah, absolutely. So there'll be different. We have break off caps that expose inlets because we actually ingest the gas into the probe. And so we have two sets of inlets that break off caps. It'll break off and it'll take a bunch of measurements kind of higher up in the atmosphere. And then they'll be processing those, actually making those measurements while the descent sphere is falling, making those measurements and beaming it back to the spacecraft in real time. While we also have the camera taking pictures once it gets below the cloud deck, as well as we have the VASI and VFOX will be taking their measurements throughout the entire descent. So we have a whole sequence of things that the probe will be doing that we'll be rehearsing, and analyzing, thousands and thousands of times. I mean, it's such an important role. I mean, I have one person that'll be on my team entirely dedicated to just having their mind entirely wrapped around that sequence and making sure that every piece of that puzzle works as we need it to for that sequence.
Yeah, because I'm just trying to think, as something enters into an atmosphere that perhaps we don't know as much as we should know about. With, like you said, strong winds and the parachute getting dragged off in different directions. Presumably, that's like insanely difficult engineering problem.
It's a really tricky engineering problem, but for those of us who are system engineers, though, we love it because it has everything. If it's an adventure novel, it's an adventure novel that has all possible plot twists, if you will, to make sure that we have to get all these different facets working together at the same time. We'll be analyzing the big distribution, what the possible winds are. What are the nominal winds we expect? What's the worst case wind? What could a gust of wind do for us? What if the clouds are a little lower than expected, a little higher than expected in terms of the density gradients? We're going to have to design for and account for all of that. What makes it even more fun, from a system standpoint, is so obviously now talked about like the Mars rovers and their descents to get on Mars. But they're just trying to drop off their payloads on the surface of Mars. They're not doing any of their science measurements during that process. They're just trying to get that rover down there, and then the rover will have time to unpack itself and go do its science measurements. No, during that intense process is when we're taking our science measurements. So it's even more critical, that we have, a thorough understanding of what needs to happen during the descent. So yes, it'll be a really fun, engineering challenges to work through. But yeah, I have confidence that our team has it well under control.
I'm assuming one of the sort of hardest elements of that is remaining in communication to actually send the data, because there's presumably no point collecting the data if you can't get it back to the spacecraft.
No, Matt, you're absolutely right. Because we're taking science data in real time, and there is no collect it all, land on the surface, and beam it back. Yes, we have to beam it all back in real time, and that communication challenge is definitely highest on our technical list to make sure that we work early and we have a dedicated team devoted to that very issue right there. So we're implementing what's called an adaptive data rate solution. So we have a 2-meter high gain antenna on the spacecraft, and then we have the S-band antenna on the descent sphere. We have to model all of the how the atmosphere may perturb the probe and how the pointing of the antennas, the pointing of the spacecraft, and it'll be constantly talking back and forth and adjusting the data rate, because you have the balance you need to strike between, if you make the data rate so slow that you are sure to get the data back, well, then you're not maximizing the amount of science you can get. But of course, the scientists want as much data back as possible. So we want to try to increase the data rate as much as possible. But the faster the data rate, the harder the connection is to maintain. So we have a strategy right now to try to strike that balance between making sure we have good communication, make sure we stay locked on, but also maximize all those fantastic pictures and data that we plan on sending back.
Yeah, so I mean, so they're really, is that where the bottleneck actually is, in terms of you can collect the data, but you can only collect so much data because you've got to be able to control this data link.
Yep. Yeah, that is definitely the bottleneck. We have, cameras, they can spit out, data and fill up hard drives, like there's no tomorrow. And we can, constantly run and refine those mass spectrometer measurements to increase the precision. But there's a balance there between how many ones and zeros you generate and how many of those ones and zeros you can get off the descent probe back to the spacecraft. I mean, we've spent years analyzing it, and we have special teams of experts looking at it, and obviously having a previous rounds of this proposal, this is the area that we've probably dug into some of the most of any of the technical areas, because it is so critical. But you're definitely right that is a bit of the bottleneck in terms of getting the data back.
So when you were designing the spacecraft, there must have been other suites of instruments that you've had to reject, in other words. Presumably they must have been quite interesting conversations.
Yeah, I mean, there's the balance of what do you fit, because we are about 1 meter diameter titanium sphere, and it's going to be packed with instrumentation on the inside. Is there more that we would like to add? Of course there would be, and even people ask could you turn it into a lander? Turning it into a lander is a whole different suite of engineering challenges, for surviving the landing. But of course, you could take more data if you're down on the surface. So there's again that balance that needs to be struck there of getting what are the key science measurements that the scientists need, and that is these atmospheric chemistry measurements, combined with making sure that we keep the mission, well within scope of a discovery mission. So
you mentioned landing. What is the landing going to be like for the spacecraft, and is there any chance that it will survive it and be able to do anything once it's on the ground?
It is definitely able to continue transmitting for about 20 minutes or so after landing, assuming that it survives the landing. Again, we have no requirement to do so, because then there's a whole suite of requirements that goes along with, and engineering development that goes along with turning it from a descent probe into an actual lander. But yes, we'll be planning for the contingency that it does survive the landing and continues to acquire and transmit data back to the spacecraft. The spacecraft will be watching it as long as it possibly can to get every last little bit back, should it actually survive the landing.
So does it have a some form of storage, so that if it is a little bit slow getting the data up because of these transmission problems, it's able to get the data up in the worst case scenario once it's hit the ground?
Well, so we have designed it such that it gets all the data back to the spacecraft before it hits the ground, even in that worst case scenario. So that's where the adaptive data rate and the onboard data prioritization that we have designed into it comes into play, is that it says this is the most important data, we'll get it back, and just keep basically going down the priority queue, basically emptying out, because yes, we do have storage on board and a queue of data that just keeps sending until it can't send anymore. Again, that's part of that trade of balancing the data return with making sure you have that robust link.
Yeah, I mean, it's like something like the camera system on there is. I mean, obviously it's a science instrument, but is it a lower priority to get the pictures back than it would be like the gas measurements and the spectrometer measurements and things like that?
Well, it depends. It depends where we are in the descent, and so that's a good question. Our data prioritization is a function of time through the descent. So there are high priority gas measurements, and then there are some secondary gas measurements. There are times when the pictures are priority, and there's times when the gas measurements are priority. And, I mentioned that descent phase lead person, again, the person who is solely dedicated to all of that thinking and how we do the prioritization will help design. Okay, take these measurements at this time in the sequence. Okay, now take these measurements. Okay, in the queue, these measurements are first in the queue. Okay, now when we get this picture, then it jumps to the top of the queue and sends it back up in that fashion. Again, all has to be autonomous because it's all occurring, with a time delay that's too great for us to control, obviously in real time.
Yeah, it's an incredibly. I mean, it just sounds. I'm just sitting here going, "Oh my god, that's stressing me out thinking about it."
but for system engineers, though, I mean that's the kind of problem that but that's the kind of engineering challenge that we live for, because you have to factor in all the things. The atmosphere is really hot, so it is slowly soaking through the descent sphere. So there's a time challenge there. You have to deal with the dynamics of it going down to the atmosphere and communication. You have the power on board for the battery. The battery only has a limited life. So system engineers are always balancing all the different disciplines together, and everything is a trade back and forth. And this really kind of is the epitome of that system engineering trade space.
Has Davinci Plus benefited from not being one of those earlier discovery missions? Did it benefit from that?
There's certainly a benefit to that in the extra 4 years or so of development, because we definitely, after it wasn't selected in 2016, they definitely didn't stop work on it at all. One of the things that was identified in 2016 was that radio link, and after that is when we implemented the adaptive data rate solution to really help make it even more robust. If we were selected in 2016, I think we would have been just fine. But did we find ways to tweak it and make it a little bit better? Yeah, we most certainly did. So yeah, there is a benefit. Any mission that isn't selected one time around and then goes through another cycle or two, each cycle, does add some value to it going through.
There's an orbiter part of this spacecraft. Is that able to stay in orbit, or once it's kind of done the transmission, this hour-long descent, is that also an orbiting piece of space junk around Venus?
So right now there's a little bit of negotiations and headquarters back and forth about exactly what we're going to do after we drop off the descent probe. So we do get there are 2 Venus gravity assists. We do take some science with our visor and our Cubis instruments. And right now we drop off the probe, get the data, and beam it back to Earth, and that's the end of the mission. But if we have a functioning spacecraft that has some instruments on board, could there be some options after that? It's something that we will definitely be exploring in the future, because the spacecraft will have more capability than just dropping off the probe.
Is often that determined by how expensive it would be to actually kind of keep it manned, as in keep the people in the mission control and the weigh that against the cost of other things that you could be doing with those resources?
Yeah. Definitely, headquarters definitely is looking at those. Are what's called phase E of the mission, is the implementation phase, and they're always looking at the phase E costs. And the more you extend out a mission, the more expensive it gets. So yes, keeping us going for an orbital phase would definitely cost NASA some more money, and that they have to weigh against all the other exciting missions that they're working on. Going back to my Lucy example, we launched this fall, and our mission goes through 2023. So we have about a 12-year 2033 2023. So we have about a 12-year mission. And so, yes, our Phase E cost for that 12 years of Lucy operations is basically comparable to what's taken for us to design, build, and launch the actual spacecraft in the first place. So the headquarters is definitely weighing that. Now, what will they do if we have a fully functional Venus spacecraft with sensors on board that's going by the planet? Are they going to say, we don't have the money for that? Yeah, we'll see what happens when that time comes. That's a little ways down the road. But of course, I want it to go on as long as possible.
But there is another orbiter. Is the Veritas? Are these two missions actually complementary?
They're extremely complementary. Yeah, it's really exciting to have them both selected together. In that we were competing against each other in this discovery round, just like we were competing against each other in the 2016 discovery round. The science that we're going to be doing is very, very different. They are a global mapper. They have a synthetic aperture radar. They have an IR spectrometer. They're a much longer mission. They have a long aerobraking phase, and their global mapping that they're going to do is going to take years to actually get all that data back. So we have our really exciting descent. That's an hour-long descent that we're going to get information to rewrite the history books on Venus that will beam back, and we'll have it back in a very short order, where it's going to take them many years to map the whole surface, where they'll be taking these detailed radar maps and detailed IR spectrometer measurements of the entire surface. So we'll compare what we see in the detail for that local area compared to the global map. And so we really are complementary in our science. When NASA selected both of these for this discovery round, they really kind of put all the chips on the table for Venus kind of together with these two different missions.
Yeah, absolutely. But they don't interact, other than being complementary. They don't interact with one another as.
No, we don't interact with one another. We already have our landing target selected for Davinci Plus. It's going to be the Alpha Regio Tessera, and on Venus they have these really tall, huge platforms, basically that we don't understand exactly how they form, called tessera. Like, I think these huge plateaus, but these are plateaus that are the size of large states, the size of Texas, something like that, size plateau. So Alpha Regio is our target, and we already have that selected, and have been planning all of our flight dynamics for that. And while yes, the Veritas is going to be getting a lot more detailed measurements of the surface, for them to the time it takes them to go get all those measurements, collect the data, and process it, we can't really action off of that information. So we have to go with the Magellan data, provide a lot of the radar data that we're using to do our targeting right now. So no, we don't have any direct interaction from a spacecraft standpoint. Will our science teams and other aspects of the missions, of course, kind of feed off each other to build the excitement for Venus? I'm certain we definitely will. Obviously, we're in the early stages of all that since it's less than a week from selection.
Yeah, no, absolutely. I mean, so what are the main sort of science goals of Davinci Plus? Have you got like a set of actual goals?
Oh yeah, absolutely. So our broad science themes are there's the atmospheric origin and evolution. We want to understand what is the origin of the Venus atmosphere and how does it evolve. And we also want to understand why is it different from Earth and Mars. Again, Earth and Venus are very similar in size, but our atmospheres and the habitability for us is obviously quite different. So how did that happen? We understand what the composition and surface interaction is. Did Venus have an ocean? And if so, where did it go? And what is the volcanic activity on Venus, and how did it potentially shape and form these tessera? With the surface properties, what are they made of? How did they get there? And how do they compare across the planet? And the kind of the big takeaways that I've been telling family and friends and other people that speak to about this is there's kind of two things we are globally thinking about. Is the analogs to Earth of, was Venus wet and more habitable, and how did it become the kind of hellish world that it is right now, and what does that mean for Earth and any climate changes going on towards Earth is one question. The other question is, it's kind of like the exoplanet next door. As we're discovering, as Kepler and the other missions are discovering thousands of potential exoplanets out there, a lot of them fall in the same range that we might expect for Venus. So are we going to help us understand? It'll help us understand those exoplanet explorations we're doing, the other instruments, especially with James Webb Space Telescope coming online sometime in the near future. It'll help us understand the data we're getting from those exoplanets by looking at this planet right next door to us.
At any point in this mission, did anyone think about, instead of descending all the way down, of trying to develop spacecraft that say stay in that sweet spot of the atmosphere where it's not too rough, and you could actually have a kind of orbiting platform that's within the atmosphere, so you can take atmospheric and ground measurements and stay there for a little bit longer.
Yeah, it's certainly, well, the Russians have actually tried to do that with some balloons that they did on Venus, against many decades ago. Have studies looked at that? Oh, absolutely. Having an atmosphere that's 95 times as thick as Earth and close to the surface, it kind of begs the question for, well, let's do some balloons. An interesting analogy. So we have a parachute that will bring our the descent probe down to around 40-ish or so kilometers above the surface, and then it releases the parachute releases, and the meter diameter sphere is then free falling. But the atmosphere is so thick, you shouldn't think of a big meter diameter ball falling like you would on Earth. That atmosphere is so thick, it's almost floating kind of more like a pebble does in a pond. It's really hard for us to visualize how thick that atmosphere is. So could you have balloons or something that's riding up in perhaps a little more habitable zone of the atmosphere? Again, the Russians have tried that, and we've had many mission concept studies that have done that, have looked at that. For the immediate measurements that we need, the instrument technology has advanced to the point where we can take a lot of these critical measurements, at least on one descent. And if we find some really interesting aspects of it, being able to put some of these instruments, on a different platform sometime in the future to take more global measurements, I'm sure there would be interest and appetite, for doing that. For this round, for a Discovery class mission, though, those kinds of things are difficult to do.
Yeah, I mean, because we've recently obviously had helicopters on Mars, which almost seems a bit preposterous, seeing how thin Mars's atmosphere is. Like, presumably a helicopter would work a damn sight better on Venus. Might we actually see that type of drone type activity on, quadcopter, helicopter style things on Venus? Is that something that comes out of helicopters on Mars?
Well, helicopters on Mars, but actually the more interesting analogy to think about is the Dragonfly mission, that's going to Titan. Talking to some of the colleagues I have that work on that Dragonfly mission, which obviously isn't launched for quite some time, because the atmosphere on Titan is about 10 times as thick, and it's obviously cold. The control laws for in terms of controlling a helicopter, because the atmosphere is so thick, it's definitely not liquid, but it's definitely much thicker than Earth and much thicker than Mars. The control laws are actually easier. Now, unfortunately, the problem with Venus is that, yes, it's a thicker atmosphere, so would a helicopter work great? It would, except for the 900 degrees Fahrenheit temperatures. That poses a whole other set of problems. I mean, we can't, that will take new technology to be able to get electronics and other mechanisms to be able to physically last that long in that type of environment. You need electronics that can actually operate sustained in that environment. So for the Venera missions, their lifetime was limited by batteries, but it is, as well as the heat soaking through. What makes us, affordable on the Discovery class mission scale is that descent sphere that we have is acting essentially like a thermal buffer. So we have what we call a transient thermal problem. So that descent sphere is slowly heating up as we're going through the atmosphere. And eventually, once it reaches equilibrium with the Venus surface, which isn't until long after the touchdown, but then nothing can survive and operate at those temperatures. So to have a helicopter that could land and recharge like Ingenuity is doing, you'd have to have something that can actually come into thermal equilibrium in that environment and still operate. And that we don't quite have the technology for right now.
Yeah, the titanium ball, as when it gets to the surface, and it's obviously, if it can operate for a few hours, and I love that whole idea of the heat soaking in, and that's because of course I guess there's no way of cooling the thing cooling it down.
Yeah, because to cool something you have to reject the heat, and there's no place to reject it to.
How long will the titanium ball stay a titanium ball on the surface when you've got all this acid and heat? Is titanium pretty resistant to that?
It is fairly resistant to that. It'll definitely become a soft ball of metal on the surface. in terms of the long-term studies, what will happen, years down the road, we haven't looked at that. We really only looked at, the descent through, again, about 20-ish or so minutes, past which we expected to be able to potentially survive touchdown. But other than that, yes, it's going to be a kind of the surface of Venus is hot enough to melt lead, not quite hot enough to melt, other metals, but it definitely doesn't do nice things to them with the sulfuric acid rain and other things of that nature.
Yeah, I mean, it's just not a nice place, is it, Venus?
No, but it's similar in size to Earth, and potentially had oceans and stuff, similar to Earth. And what happened? What the heck happened?
Yeah,
that's what we want to try to figure out.
Yeah, I mean, we've certainly had this on the podcast before, where it's always a little bit surprising how little Venus gets talked about, considering how much Mars gets talked about.
Yeah. Yeah, I mean, Mars is 1/100th the atmosphere. It's got about the third of the gravity, and I mean, Venus really is our twin, an evil twin, but it's just it's certainly our twin, and we're looking for analogies in the solar system. I mean, obviously, it's not hospitable now, but it's really the closest to Earth, and boy, do we go down different paths. And understanding that, is helpful for us to understand the evolution of habitable worlds, throughout the throughout the galaxy.
Yeah, I mean, I guess it. I mean, it does stand as a pretty convincing argument, doesn't it? That you can that if your atmosphere and your weather get out of control, it can be pretty serious, right?
yes, definitely can get serious. Now, that's not to say that we're exactly on the path of 95 atmospheres and 900 degrees Fahrenheit temperatures here on Earth, but the more carbon dioxide we pump into the atmosphere, the more raising we are creating a greenhouse effect, and the Venus atmosphere is the greenhouse effect that has completely run away, the greenhouse effect on steroids, and we obviously don't want Earth to even come close to going down that path, because that would not make for a good day.
No.
So that's why it is important, because I mean, Earth's oxygen came from biological sources billions of years ago, and so obviously we diverged in how we got the atmosphere and the climate that we did today, and it is changing, and where do you extrapolate that trend out to? Well, that's one way to perhaps help us understand that.
Yeah, I mean, it's like you said, it's an extreme extrapolation, but it still acts as a control. We've only got one other measurement, and that's Venus. I suppose.
Exactly. Obviously, Europa and Enceladus they get a lot of play time as well, being ice worlds, and those are really exciting for the scientific possibilities there. But those come from very different processes. The gravitational pull of those large planets creating those energy sources, that are heating up and creating those liquid oceans here, but the processes on Earth and Venus, should have a lot more analogs to each other, and that's what we want to understand.
Yeah, well, I'm really, really chuffed that Venus is getting a bit of love. It definitely needs it. So, maybe the Europeans we can send something good there too. But when Davinci lost out, Lucy was one of the ones that got picked, and you're part of that mission. So has your involvement with Lucy and your technical know-how on that and obviously management, etc., has that put you in the position to be where you are for the Davinci mission?
Yeah, most certainly. I've had a lot of technical leadership positions throughout my entire career, both at San Diego National Labs, JPL. I've worked at Air Force Research Laboratory, so I've been around a lot of different institutions and done a lot of varied things throughout my career. But working as one of the lead engineers on a planetary mission such as Lucy really helped me understand how to form the right team to get the right people working on the problems. I've mentioned several times about some of the specific engineering challenges that we're going to have throughout the Davinci Plus mission. Identifying the right people to put them in charge of those various areas is something that I definitely learned in the team building that I helped with Lucy, since I was part of the Lucy since right after selection all the way through to our launch here this October of 2021. And there's the different aspects of planetary missions where you have planetary launch windows that are very constraining, unlike a lot of the Earth missions or science missions where your launch opportunities are fairly continuous and you're really more limited by launch site availability and budgets of continuing going. Whereas the planetary world, you have to hit your launch window, and there's much stronger drivers. The missions are typically longer. Again, Davinci Plus is actually very short for a planetary mission, but you have a lot of the same drivers that you need in building your team and how you manage a team and how you solve technical challenges.
Yeah, and I noticed that your background itself is really, really interesting. Can you tell us, how when you first got interested in space and your entire journey, because it is a really fascinating one.
I've been a space and sci-fi enthusiast my entire life, and so that's I can't even pinpoint a start date for that. Loved Star Trek: Next Generation growing up, and of course all the Star Wars. And I have always been an avid sci-fi reader, even the classic, Clarke and Asimov books. So always been a sci-fi enthusiast. It wasn't really until I went into grad school. I actually started grad school at Caltech and JPL doing research on propulsion, that I realized, hey, not only could I read about it, but I actually could become part of it and do it, which was so really exciting. I had so many great mentors there at Caltech and JPL as a starting point. Unfortunately, my career was interrupted a little bit because I was in the Army, and so I actually got activated after September 11th and actually did a combat tour in Iraq as an armored cavalry officer, leading urban combat ops in Southwest Baghdad for a while. But I always knew I wanted to return to engineering, and so after several different fun things that I did in the military, did end up returning to my engineering background and did space and missile system work. Did my doctorate at University of Michigan on advanced spacecraft propulsion, researching these different systems that can really enable whole new realms of exploration. And we're starting to see it with the Psyche mission is going to be able to do here when it launches shortly. Of course, with the Dawn mission did with its ion thrusters, and then eventually made my way to NASA Goddard, and have tried to work the planetary mission since I got there, and had an opportunity for Lucy and took it, and was really eager about taking the leadership role for Davinci, and excited to see this one through.
Did you find that your spell in the Army has given you this like an extra perspective on management style? Is that something that you're able to bring to the table as well as your engineering skills?
Yeah, no, absolutely. My military experience and my officer training has helped me tremendously from the management side of technical leadership, because it's not just about how smart you are, or how well you know the equations, or how well you understand the hardware. You have to manage the people, and people management is the same in any facet, whether you're in the military, whether you're in the financial world, whether you're in the engineering world. You have to know how to lead people, to motivate them, find what gets them excited, make sure you get them in those roles to get them solving the problems, because the Davinci Plus mission has a great team. It's not me designing it, it's the team that's designing it, and making sure that that team is led through all the different challenges. As problems arise, you make sure you give your folks the resources they need to be able to solve the problem. Sometimes you need to act as a little bit of a buffer to give them the space they need to solve the problems, to bring back the solutions to the management chain for approval. So absolutely having both done academic research, done a lot of other projects in different institutions, as well as having military leadership, it's definitely helped me prepare for the multi-partnership role that we're going to have here in Davinci Plus.
Yeah, I mean, and does working for NASA, I mean, because everyone I talk to who works at NASA seems to have this like really quite extraordinary kind of personal growth as they work their way through the institutions. Am I getting that right? I mean, is NASA this really amazing place to work?
It definitely attracts some really top talent. It is, I mean, everyone always has that kind of cool factor, that wow factor for different things that they do. And sometimes you'll get it early in life, and then you kind of settle into a career, and this type of a career working on these spacecraft and these missions, where it's it's exciting no matter how far you get into it. Talking about going into the atmosphere of the planet is exciting no matter how old you are, no matter how far you are in your career. For the Lucy mission, I've been out, spent a lot of time with this and a lot of good quality time with my spacecraft out there. It's so beautiful to see that hardware, the big vacuum chambers, the big cranes, the big facilities that we have, the big shaker tables to be able to run these tests. For Lucy, we're going to be the furthest solar powered mission ever in history. We've got these 7.3 meter diameter flexible ultraflex arrays that are going to go even past the orbit of Jupiter, operating on solar power. And when I saw those things deploy for the first time, there's a cool factor that you can't describe in words. Just seeing that hardware, I call it firsthand photons. When you're seeing something, for yourself, with your own eyes, that is exciting, and that's what motivates people, and that's what can draw the great talent that NASA and all of its partners do.
Yeah, I love that phrase, first-hand photons. That absolutely sums up my experience of getting back into space after I bought myself a telescope and saw Jupiter with first-hand photons through a telescope, and you go, "Oh my God, it's actually Jupiter!" And it's a different experience, isn't it, to just looking at it on a photo.
It totally is. It totally is. I mean, you can see, like, for my similar experience is actually Saturn, seeing the rings of Saturn. I've seen so many of the Cassini pictures, and they're absolutely gorgeous. But when I first saw the rings of Saturn through a telescope, and I knew that light had gone away from the sun, had bounced off those rings, bounced off a few mirrors and directly into my eyes, knowing that a journey that it took to these amazing places. So it just it's a psychological impact, that really helps motivate it. And getting the people to do this amazing thing, takes that kind of that human factor to make it happen.
Yeah, I mean, one thing that also strikes me is that, like, you did your PhD in ion thrusters. Yeah, as you get sort of further up the ladder in terms of being the lead engineer, etc. Do you get further away from the actual engineering and it becomes more of a case of management? I mean, obviously you still need to have the engineering knowledge to be able to manage these engineers, but do you get slightly more, because it always seems a pity to me that you've got that someone with a PhD in ion thrusters isn't actually engineering ion thrusters at the moment.
There is, I cannot deny there is an element of that. Is I am not running the calculations, myself. All I told you about, all these analyses we've doing for the Sensphere going through the atmosphere, my team's doing that. I'm not running that. All these flight dynamic trajectories that we have, an amazing flight dynamics team that's running all of these. They're doing those calculations, and not myself. These thermal analyses, there's another team of people doing that. So there is a little bit of there's a little bit of sadness inside. The nerd inside of me is a little sad that I'm not the one actually running those numbers anymore. But when you see the results that your team are coming up with, it does, the leader inside of you gets motivated by what they do. And the thing that I love about the project system engineer role, that I loved about Lucy, and that that I'm finding the same thing to be true at Davinci, is that I had to deal with so many different technical challenges that a lot of them are outside my expertise, and you have to apply that same engineering methodology, same engineering thinking to be able to solve all of those, to gather the data, to synthesize a response, to understand the situation, and to help develop the path forward. As a lead system engineer, you don't have to know the answers. You just have to know how to get to the answers, and that's using your team's abilities to be able to get to the answer. So you have to understand it enough to be able to get to a good technical solution, even if you're not turning the crank yourself.
Yeah. It's very fascinating. That's super fascinating. Well. Thanks very much for talking about these missions. I've got a couple of frivolous questions that I always ask my guests, but you haven't been prepared, so I'm that you may not know them. But I always normally ask two questions, and one of them: have you got a hero from the past, a person that no longer lives anymore, a dead person from the past that you would bring back and say, hey, look at what we're doing. Isn't this incredible? Who would you bring back from the past to show your work?
Honestly, I would probably Carl Sagan. Would love to have him see what's going on right now, both in terms of the science that we're doing and the outreach portion of it, the public enthusiasm for that. It would be one, and I'm going to give, since I wasn't prepared, I was going to give you two answers as well. Of course, Werner von Braun with the what was done for the Apollo program is truly amazing. And if I could go back in time and be part of anything, I would love to be, one of the lead engineers on Apollo, because it's such an exciting era of aerospace history. And it's what we're able to do now is would be amazing to show them. So those are my two answers.
Yeah, well, that is quite diverse as well. Von Braun and Sagan. I mean, you certainly can't. I certainly can't argue with those two choices. Yeah, I mean, if you do manage to get Sagan back, get him to come on the show, get him to come on the podcast, because that'd be absolutely well. And Von Braun's coming to. That's said. And the other frivolous one is: do you have any piece of music that you associate with space, or that you associate with anything really that can go on our space song playlist that we keep? I almost gave you Lucy in the Sky of Diamonds then, but because I could see the Lucy picture in the background with a diamond next to it. But
So Lucy is named for the Australopithecus fossil, which was named after the song, and we actually do have a plaque that we put on the Lucy spacecraft that has the drawing that John Lennon's son made. So I'll definitely, in honor of Hal Levison, our PI for Lucy, I'll definitely say Lucy in the Sky with Diamonds.
There we go. I accidentally put it. It's going on actually, because it isn't on, but it is actually a good shout.
Yeah.
I just couldn't resist, because I could just see the poster right next to your head.
Yeah, no, we do have a shout out to that as part of the mission. And our PI is a huge classic rock fan.
Nice.
So we actually often talk at our meetings.
Wow. Well, that's really cool. Well, thanks very much. That is absolutely awesome. I'm really looking forward to this mission. What's so annoying, isn't it? That, well, I guess you're not annoyed, but for us space geeks is how long these things take.
Yeah. Unfortunately, so we did. All of the Discovery missions had proposed a 2026 launch date, and unfortunately, due to the budgetary pressures of the NASA, they've asked us to push it out by a couple of years. So, I admit it, we are a bit frustrated by that as well. We're excited that we're picked. We're excited that us and Veritas will be going together. But would we like to launch in 2026 instead of 2029? Absolutely, we would. But we're picked, so we can't complain.
So 26 and 29, are they launch windows for Venus then?
Yes. So there's one in May of 26, there's one in January of 28, and then there's both one in August and November of 29 are our launch, or again, some of the constraints we have. So we have to combine when you see the saying, when the planets align. Well, for us, we truly need the planets to align, and they have to align with the budgetary realities of NASA. I'm not going to say which one's harder.
Excellent. Well, that's a great place to stop. Thanks very much for spending the time with us, Mike.
No, happy to do it, and happy to keep you guys up to date as we progress through development. So it should be exciting.
Yeah, and I've got to thank Tupper for organising this. So thanks, Tupper.
The Interplanetary Podcast is alive!
There you go.
Fab.
And I might have some European Space Agency news on the same subject over the next couple of weeks as well. Ooh. So we can look out for that one as well, Venus related.
I'll keep an ear out for that.
I want to do a shout out to patrons. Can you help me?
I can certainly help you, of course. Let's do it.
These are absolute legends. They're all chattering away as we speak in the Discord, and often some of them come on. They do episodes with me or give me guests. Oh, it's just genius. So here they are: Bob Hodges,
John Banak,
Niklas Gillenstein,
Kenton Hawkinson,
Ronald Hatcher,
Marissa Davis,
Tupper Hyde,
Malta Keisling,
Rob Annable,
Mark Schum,
Neil Hansen,
Christopher Andreasen,
Stas Shusha,
Gene Wojcicki,
Alden Vala,
Bob Moore,
Jordan L. Kurdi,
Jenna Tiwana,
Al Broom,
Steve Croucher,
Mark Kelly. A little bit of me hopes that that's the actual Mark Kelly.
Jim King,
Jim King, by the way, is the nicest human being on earth. I just want to point that out.
Absolute.
the Swiss Army knife of glory. Paul Hilton.
Adam French.
What a gang! That's massively grown as well. As I was reading that out, I was thinking, crikey, it's becoming quite an army.
Yeah, absolutely.
I think there's enough of us now to start our own space agency.
Without a doubt. And as soon as my Bitcoin goes back up, I'm paying for it.
Yeah, thanks, Elon Musk.
Bombed out there.
Yeah, it's like, Elon, could you tell me when you're going to do stuff like that, please? I mean, seriously, he must be able to make his friends really rich, right? Because he just goes, right, tomorrow I'm going to tweet about Bitcoin being dropped and how ace Dogecoin is. Just quickly swap them over.
Yeah.
I mean, literally, I wonder if he's got a bunch of mates who are all laughing down the back, all laughing their way to some very expensive holiday.
Billionaires are involved in an infinite jest with us, without a doubt. They are laughing. They're laughing at you. They're laughing at me.
Talking about billionaires, there's quite a lot of humour going on about which of them is going to go to space first. Because it looked like it was Jeff Bezos, didn't it? Because Jeff Bezos is going to be on the next New Shepard, which might be very soon. So we might see Jeff Bezos go into space, which is a pretty great story. But someone's saying that that Elon Musk may have bought that extra seat, and because Elon Musk is slightly taller than Jeff Bezos, he will go into space just a tiny bit before him. But
I love it.
But we might have a Brit beat them all, and old Dickie Branson, old Dickie B, might actually go up on a Virgin Galactic and just pit them to
Dickie.
it.
You know, we need to win at something in this game.
We do need to win at something. Come on. So I'm rooting for Dickie B. Who are you rooting for?
Dickie B all day.
Dickie B all day.
Dickie B.
Brilliant.
Yeah.
And
after that,
B.
I think I'd like to see Bezos go. I think I'd like to see him just to see him beat Elon Musk.
Yeah, well, he's got to have a win somewhere, hasn't he, old Bezos?
Exactly.
I mean, I really feel sorry for him.
Yeah, of course. Yeah, it must be awful for him.
What are you doing this week, Chris?
I'm starting a new job, Matthew. I'm starting to work for the Liverpool Arab Arts Fest. I'm going to be their education producer. So I am excited, anxious, and looking forward to getting back up to full speed. It's been a long time. I spent over a year just working on quite a low burner, so I'm going to be very busy. But it's time to step up again.
Well, congratulations.
Thank you very much.
You got a good old job.
How about you?
I should be plodding. I'll be plodding along with the same old job. Having to go in now though, which is a little bit distressing.
Don't do it. Work from home forever.
Commuting.
No to
where's
pants.
Lockdown?
No to trousers. No to trousers.
So that's it. Bye, Podcast.
Podcast.